Let's spend just a couple minutes taking a look at the function that generates a normal distribution. So the first thing we can do is we can create a vector, which is the normal distribution. Remember the norm function is that, and it takes three parameters: how many samples or how many data elements to generate, the mean, and the standard deviation. We can execute that. We have a simple little vector. We can take a look at the structure of that, for example. It's a vector of 100 numbers, because we told it to do it 100 times. And we can see there around 50. And we can do a histogram of A. Now when we do a histogram, it shows up here in the plots part. And we can see that it goes from 44 to 56 with not a very smoothly shaped histogram function. And we can kind of combine those two lines. So we can do hist or norm 152. Each time I do it, generate different sets of numbers, which means I generate different histograms. Now they're close to being kind of that bell-shaped curve. Each time they're just a little bit off, and that one is really kind of not so good. Now, what can we do to kind of make that more impressive, if you will, or more accurate? Maybe is a better way to say that. Is we can add more samples. So rather than just doing 100, we'll do 100,000. How's that? So we can kind of do it a couple times, and we can see that that looks like a much more accurate bell-shaped distribution. Again, we can store the result rather than actually just doing the function. So I just wanted to because of the two parameters there. So more accurately would be that way. If you look at B against a vector of 100,000, and they're roughly around that. You can take the mean of B, take the standard deviation of B. I can do the max of B. So I can do all the standard descriptive stats that we did before on normal distribution. And again, I can also do the hist of B. And here we go. Now, if I wanted to, let's do this, but now instead of the mean of 50, if I change it to, oh, I don't know, how about 75? Okay, it's around 75, so that makes the most sense. And if I said instead of just standard deviation of 2, if I made the standard deviation 10, see the range is broader. And if I do it again, it changes a little bit, but not a lot. Go back to 2. Again, just the shape looks fairly same. The only thing that we're changing here is kind of the x-axis and how spread out the actual bell-shaped curve is. And just like before, we can store the results of this. See, we can store that. Now, if you want, we can actually take a look at a subset. Let's kind of zoom in maybe everything above 80, see what that looks like. So we can do D, a new variable, equals, from the vector C, everything in C that's greater than, what did I say, 80. What do we create in D? 629. Take the mean of D, it's around 80. We can do a histogram just of D. So we're kind of just going to do a histogram of everything out here, to the right, if you will. That's what we have. So we have not a bell-shaped curve, kind of more like that J Pareto distribution we've seen previously, but it's really just the tail of the distribution. We can do the same thing, but zooming in even more. Say 82.5. What's the structure of D now? 11 numbers. And we can do the hist of D. And there's really just a couple numbers out here. So once you get to the very small tail, it's a function of randomness again a little bit. So I think we'll stop there and just kind of have kept that a small little review of the normal distribution function and how it works within the RStudio environment.